I'm Pravi. I'm an 8th grader in middle school from Konkan, Thailand. Hello, my name is Tongpong. I'm an 8th grader in middle school from Konkan, Thailand.
Hello, my name is Shogun. I'm an eighth grader from middle school in Konkan.
Hello, I'm Sari. I'm an 8th grader in a middle school from Konkan, Thailand.
Hello, my name is Yaya. I'm also an 8th grader in a middle school in Khon Thailand. And our project is, can LED lights replace sunlight for plants? The reason that we decided to choose this topic was because at night we don't have any sunlight, and we figured if LED lights could eventually replace sunlight, we could use this as our advantage. Now, this is our video representing our science topic.
Hello everybody! Today my group and I, consisting of Yaya, Pradvi, Shogun, Sari, and Thunfon, will be presenting our project. Can LED lights replace sunlight for plants? But before we can answer that, we need an introduction first.
LED or light emitting diode is known for its energy efficiency and long lifespan. But how does artificial light compare to sunlight? Before we can answer that, we need to know what is essential for plant growth before we can compare.
Plants need several elements to grow, for example, water, light, air, nutrients, temperature, and more. Light is critical because it drives the process of photosynthesis, which plants use to get energy. The light spectrum intensity and duration all influence plant health and growth or development.
Sunlight is a full spectrum light source, meaning it contains a wide range of wavelengths, from ultraviolet to infrared. The broad spectrum is essential for various plant processes. LED, however, can be engineered to emit specific wavelengths. Modern LED grow lights, as these wavelengths are crucial for plant growth and photosynthesis. The red LED lights promotes flowering and fruiting, while the blue LED lights it's for leaf development. Some advanced LED systems also has white lights or additional wavelengths to mimic natural sunlight more closely, and along with that, it also converts all needs for plants.
Materials: 2 identical containers, 4 mung bean seeds, 2 per container in case one didn't grow. Same type of soil for each container, water, spray bottle for watering, LED light with adjustable brightness, camera to take daily photos of the plants, small cloth under each container to soak up extra water so the soil didn't get too wet. Method: we planted 2 mung bean seeds in each container using the same containers and soil. 1 container was placed in the garden where it got indirect sunlight, so it wasn't direct sun all day. The other container was placed indoors in a dark hallway with an LED light. The LED light was set to a low brightness, simulating indirect sunlight. In the evening, the brightness was reduced further and the light was turned off entirely at night. Each morning, the light was turned on again to maintain a consistent day-night cycle. Both plants were watered twice daily using a spray bottle, once in the morning and once in the evening, to keep the soil moist without overwatering.
This experiment demonstrated that while both natural sunlight and LED light support mung bean growth, natural sunlight seemed to promote more balanced growth. The plants under sunlight had slightly taller stems, while those under LED lights developed broader leaves at the top. likely as an adaptation to weaker light. And that concludes our today's experiment. Thank you for watching. Bye!